Hello, everybody. Sorry for any delay. I thought we were going to have a video before we started, but we seem not to have. So we will start at this point. I'd like to welcome everybody to this fourth in a series of 4 webinars. And today we're discussing the really vitally important issue of fire. Obviously, in the wake of Grenfell, in the wake of what I think we can all agree was an absolutely disgusting tragedy, there have been changes already. We know there will be more to come. But we're looking particularly today at the impact of the changes to Approved Document 7, which came into force on the 21st of December 2018. And what this means in terms of design, in terms of how we can guarantee or at least be sure we have good workmanship, and what this means in terms of product design and manufacture as well, because all those elements we know have to be right. We've got a great group of speakers here who you can see on the bottom of your screen, or you can see most of them because one of them is going to be a recording. So we will in due course be hearing from Jim Glockling, who is former technical director at the Fire Protection Association, from Jamie Davis, of the CEO of Part B Group of Fire Engineers, John Duffin, who's managing director at Keyfix, and we will have a recorded presentation from Marcus Emerson at IG Masonry Support. Before those, we will be hearing from Richard Smith, who is Head of Standards, Innovation and Research at NHBC. I'm going to ask him to talk in a moment. But before I do, can I please remind all of you that there will be a discussion at the end. The discussions have often been the best part of these presentations. And do please start sending in your questions on the question button as soon as they occur to you, so you don't forget them, and there are questions directed at all our speakers. So I think without further ado, Richard Smith, Head of Standards, Innovation and Research at NHBC. Over to you, Richard.
Okay, good morning. Thank you, Ruth. Hello, everybody. Good to see you all. And I just thought to give a bit of a background as to where NHBC are in relation to non-combustible cavity trays, and a bit of background of how we got there, really. So I'm going to go back to 2018, 2019, where DLUC made a statement to require non-combustible cavity trays on buildings with a floor above 18 metres high. And that was actually a requirement in Regulation 7. So it wasn't actually in the approved guidance. It was actually there as a requirement. At the time, we were a little bit concerned about that at NHBC, because although there was a requirement in Regulation 7 for a cavity tray to be non-combustible, we do have to remember that there are other functions of a cavity tray within the building, as in resistance to moisture and its durability and its performance, particularly on buildings of such a height. We genuinely felt that there was a bit of a risk there. So we contacted MHCLG, it was at the time, to raise those concerns, to say that actually we felt that the industry needed a little bit more time, so there could be manufacturers that could go down the third-party certification route. So a non-combustible cavity tray could be fully tested to prove its durability on tall buildings. We had face-to-face meetings with MHCLG, and we put that in writing to them, and it was sort of accepted at that stage that things had progressed too far, and the requirement was there. So we then spoke with a number of manufacturers to talk about an acceptance process during an interim stage where we encouraged manufacturers to go down the third-party certification route. And Keyfix was one of those manufacturers that went down that route. And with that, we worked with technical approval bodies such as BBA and Kiwa to carry out a requirement or criteria requirements for durability of non-combustible lintels. Also during that time, we had an interim acceptance process via our own NHBC accepts that enabled manufacturers to have an acceptance from NHBC whilst they were going through that process with Kiwa or BBA. And in relation to that, we also had internal processes with NHBC. So, for example, we logged every building over 18 metres high that we're using such cavity trays to make sure that the cavity trays that were being used were the ones that were going through third-party technical approvals and had an NHBC acceptance. And we kept a record of all those. We also developed process documents within NHBC to advise our surveyors and inspectors of the key risks associated with inspecting each of the various types of non-combustible cavity trays, because they did differ, and what to look out for and what to ensure what was happening on site was correct, so the installation was correct. And the main reason for that is because we didn't want to have the risk of a systemic failure of lintels performing as to achieve the right fire resistance, the right non-combustibility, but not able to perform other functions, as in keeping the building dry, and also ensuring there's no corrosion or any kind of movement or thermal shock within the building. So we did all that, and we felt as though that process was going okay. And we were encouraged to see that a number of manufacturers did obtain third-party certification for non-combustible products. So we're going to move on now to this year. We are all aware of the relaxation that came into force on the 1st of June 2022. And again, we have made comment to DLUC to advise that although it's a relatively new product, there are manufacturers out there within the industry with appropriate third-party certification that can actually support the industry in providing non-combustible cavity trays on buildings over 18 metres high. And we raised that concern, but again, we've been advised, because it was actually a relaxation in legislation, nothing more that can be done. But there are some nuances in that, though, in the basis that if you have a building where your building regulations application was submitted before the 1st of June, then it implies that you should still continue to use non-combustible cavity trays. It's only for buildings where building regulations applications were submitted after the 1st of June 2022, and in England only, as far as we're aware, where the relaxation applies. So there are some developers that may think that actually withdrawing an application and resubmitting an application may get around that, but you are likely then to be the full requirements of Part F, L, O and S would apply to that building. So there is a challenge there. So from an NHBC point of view, we feel as though the industry is ready, and we have met with our mainly major builders to sort of advise of the relaxation, and to perhaps talk about the risks associated with applying and utilising that relaxation. And the main risk is, in my view, is that at the end of that 18 months, it's not overly clear how that relaxation will end. And also, we are going through probably the most significant change in the building regulatory framework, if you like, or structure, where the HSE are now becoming the building safety regulator. And in relation to that, there are a number of buildings that are going through the current building regulation process that are actually going through the building regs application stage at this stage with their preferred choice of building control body. But due to the length of time of some of these projects, that the handover of those buildings may actually end up with under the control of the building safety regulator. Now, I can't say at this stage whether the building safety regulator will accept buildings with combustible cavity trays or non-combustible cavity trays, but I would suggest it's an uncertainty. It is an area where as an industry, there will be a requirement where the developer has to make a building safety case to hand the building over, and that building safety case will have to have the full details and specification of the construction. And in my view, it could be considered as a risk to a developer to hand over a building at that stage with trays that aren't non-combustible. So NHBC's current position is that we're meeting with our developers again this afternoon, is that we are continuing to encourage the use of non-combustible cavity trays. We recognise that the requirement for the relaxation only started from June 2022. We cannot enforce any builder or developer to use non-combustible cavity trays, but we do require any cavity trays on buildings over 18 metres high to be of a system that has some form of third-party certification, regardless of whether it's non-combustible or not. And that is due to the fact that these trays are far more exposed and far more, there's far more of them due to the nature of construction. And in general terms, the builders and developers that we are working with recognise the same kind of risk that NHBC recognise, and they seem to be actually supportive of that kind of approach. There are some developers that are seeing some challenges financially at the moment that are sort of pushed into having to review this approach. And it's unfortunate that as NHBC we've got this position, but some of the other building control bodies in the industry are applying the full relaxation or not clear on their position, and some developers are moving around to achieve a lesser standard, although meeting the building regulation requirement. And I think it's fair to say that they are still meeting the building regulation requirement. So to summarise, we are working in a challenging environment with the way the regulatory system will be set up. There's a lot of unknowns in the future, and that is why we are encouraging builder customers and developers to continue to use non-combustible cavity trays and cavity tray systems in those buildings. And again, to say that even if they are not non-combustible, we do recommend that they have the appropriate third-party certification due to the height and complexity in their nature. And that is basically where we are at this stage, Ruth.
Thank you so much. And thank you for giving clarity to an area which obviously is confusing, fast changing, and we don't know what's coming in the future, but you're giving us a strategy for dealing with it and approaching the future. We'll now move. I would just remind everyone, do keep sending your questions in when they occur to you. They will really enliven our debate at the end. I now move on to our second speaker, who is Jim Glockling, who is former technical director at the FPA and has done a lot of research in this area. Jim.
Okay, thank you very much, Ruth. I just need my slides to come up if possible, please, and I'll whistle through them. So taking a slightly abstract look at this as a topic, really looking about who's behind specifying the need for non-combustible materials. Many of you listening to Richard's talk there may be sort of rather horrified that you have to battle to make this argument, because to many it would seem like a no-brainer. But there are some competing things out there. Richard mentioned cost, and of course sustainability inevitably drives us to the use of combustible materials. But I'd like to just first of all look at the key players, because it doesn't just come down to compliance. There are other actors at play here that have a very great interest in how buildings perform not just up to the point of compliance, but beyond, so there's something savable afterwards. So we obviously have a requirement for government legislation, but as I described, compliance is actually very weak when it comes to business and property protection. And those are of value to obviously the client, who may want to protect their business accordingly by having a higher level of protection than they can get away with just under compliance. And also they may want to elevate certain business credentials, such as sort of sustainability credentials, which obviously act as a sort of seesaw on the combustible, non-combustibility argument. And then, of course, we have the insurer as well, who would like to minimize the extent of loss at any given time. And that goes for both fire spread within buildings and between buildings. So I was just going to have a very quick look at each of those in turn, and you very quickly start to understand why non-combustible materials have a very substantial role to play. Now, in terms of our building regulations, they're not designed to stop fire. Every specification of method and product is just about delaying things for a period of time. So we're very used to fire compartments being effective for 60 minutes. And this is to support evacuation. But we must always bear in mind that after this 60 minutes, there's no requirement to achieve anything. It really is the compliance assures that their safe evacuation occurs before collapse of the building. There's no requirement to put the fire out. There's no requirement to save the property, to leave something that is recoverable. And so total destruction could be a completely acceptable outcome. But we're not used to that. And the reason why we're not really used to that is historically, we used high-performing materials such as bricks and mortar to achieve the fire safety goal. And this was a very prescriptive approach. And so generally buildings did outlast the fire, and things remained standing that could be recovered, and fire was constrained to smaller areas. But also with this enhanced structural capability that they had, it meant the fire and rescue service were in a position to be more effective as well, because obviously their remit is a risk-based approach, and certainly they should not be taking risks to save property unless it's very safe to do so. So we need to bear in mind that the level of performance was that we've come to expect was actually just completely coincidental to meeting a life safety requirement by the use of high-performing materials. And as we move to a situation where we might see more building in wood, and as we are, we may see building performance being very different indeed. And obviously we've had a number of events recently where buildings seem to have performed strangely and generally often resulting in total destruction, as in the case here. These are examples of sort of light timber frame buildings and modular construction and SIPS constructions, all introducing sustainable materials and high levels of insulation, but with products which are combustible. Now, nobody died in these events, and they might even have been compliant, but we've got a question as to whether these are design successes at the end of the day. So now let's have a little look at the client's perspective on things. The CEO of any company has a duty to make profit, not harm their workers, and also to act in the long-term interests of any business. And really that brings in the idea of resilience across all areas of the business. And how buildings perform can play a very major role in that. But they also have other constraints as well, and things that they would like to pursue, such as sustainability and to be seen to be a good company. Now, modern building designs, many involving large quantity of combustible materials, can certainly meet sustainability requirements and improve reputation. But if they're not done right, it can erode resilience, flexibility, and safety. And obviously, uncharacteristic loss can lead to reduced profit, growth, and reputational damage. Now, the way that businesses normally address this is through the creation of a business continuity plan. And this is an opportunity where you can set voluntary objectives over and above compliance. So rather than specifying that fire should not break out of a compartment for 60 seconds, maybe you say, actually, the fire is just not allowed to spread at all from that compartment. So you essentially make that time infinity. And you would use materials and suppression systems to meet that objective. you can actually get quite holistic and actually say, let's make sure we never exceed the critical business damage threshold for the business, however that's specified. And really, with the performance-based engineering approaches we have for this, it's as easy, or they're absolutely applicable to design to that, rather than just ensuring evacuation before collapse. It's just a different measure that you set to achieve. And really, the role of combustible materials in this is the three parts of business of resilience are really susceptibility. They can reduce the susceptibility of a fire starting, because you can't light them. They can reduce vulnerability once a fire has started, and that fire will spread less far, and obviously improves recoverability once the fire's out, because hopefully less has been damaged. Now, business continuity planning is really planning for the unexpected. It's an extension of scope from what compliance might deal with, and also your credible worst case scenarios might be different as well. There's a question, it's how far you go, how deep your pockets are. Obviously, we'll remember in the 1970s that dreadful televised event of a giant kitten knocking over the post office tower. Really, that's an event where critical infrastructure gets damaged, but highly unlikely. I'm sure there are more reasonable things to deal with. But this is how the client would normally deal with enhancing the resilience of their business through adopting voluntary objectives for how the building might perform in fire, flood, escape of water events over and above that low bar that compliance sets. Now, if we have a look at the insurer, they have a key figure called estimated maximum loss. They need to have a good idea of how a building is going to perform in fire. Now, in a normal building, let's say traditional building, you may lose, in a multi-story building, you might lose the fire floor, the floor below to water damage, and the floor above to smoke damage. And so they would be assuming that maybe out of a 17-story building, you lose 4 floors, and they give insurance on that basis, which is obviously a lot cheaper than assuming the whole building gets burnt down. But as we move to use of combustible materials, that can become a very difficult equation to balance. Really inherent in that is the use of concrete floors, and we see modular construction designs come in which actually don't even have a floor plate. We see increasing use of, obviously, timber structures, green walling, all these things which can promote fire spread over the outside of the building, and really by some methods, combustible voids spread fire within buildings as well. So that's really the way they deal with things. And also, it's not just about the individual building as well. It's spread between buildings also, which brings in the issue of combustible claddings as well, and proximity. So there's the sort of 3 players at play. And I guess in a utopian world, when you're setting the design for any building, you'd consider all these 3 elements: the architecture-driven, the form and function of the building, what it has to do; the legislature-driven properties for life safety; and then the business and insurance-driven merits of the building to protect against fire, flood, escape of water, security, social unrest, what have you. Anything you might like to think that for where your building is needs protecting against, to actually come out with a building design and safety objective. So it's quite a utopian view, but we're working on mechanisms and really enhanced guidance to support this, where really you might have a building where in the design period and actually good consultation takes place. So yes, it meets the compliance requirements, but we know that to be a very low grey bar, which doesn't guarantee that your building and business end up trashed at the end of it, but everyone is safe. But proper consultation with the client to support their resilience and sustainability objectives, and with the insurer to introduce these voluntary objectives, which the designer can work to using the normal toolkit of parts that they have. And there's a lot of guidance out there to assist as well. There's certainly, from an insurance perspective, there are the essential principles for the protection or enhancement of fire, flood, and escape of water protection, until you come out with a satisfactory solution that really is appropriate to all stakeholders. I just wanted to close off really by saying that it's inevitable that we're having a future with more combustible materials, certainly in having a lot more wood in the construction of buildings. But I see the use of non-combustible materials as the enabler for this to actually happen. And that is where you use non-combustible materials, where they can make up any shortfall, and where they need to be to where really just wood can't do it. And certainly designers are responding with hybrid building designs at the moment, which represent a very significant contribution to carbon reduction, and yet are ensuring the structural integrity of the building under fire, so that they become insurable, and the fire and rescue services, they stay sound for them to do their job. I don't think this change has been appreciated by government yet. And if we're not and at the moment, the insurer for some breeds of building is becoming the de facto regulator, which is not a role that they should be holding, or that they would want. And really more action needs to be required. So we do need some new guidance, which actually does bring in resilience into the equation. Otherwise, we may be facing a new normal where more buildings do end up on the ground, maybe even where multiple buildings become involved in fire. And of course, if we do damage the reputation, as cladding's reputation has been damaged, we could end up with a whole breed of buildings that we need that basically loses its reputation and becomes disgraced, leading to a stagnation of innovation in construction. And of course, there can also be possible safety issues with this as well. So that's all I have to say. Thank you very much, Ruth.
Thank you very much, Jim. Again, very clear, and lots to talk about, lots to think about. And yes, we really don't want an industry that is effectively regulated by the insurers. Again, do keep sending your questions in. We now move on to our third speaker, who is Jamie Davis, who is CEO of Part B, which is of the Part B group, which is a fire engineering company. And I'm sure he'll have a lot to tell us about. And as I said, if it does inspire you to ask a question, type it before you forget it.
Thank you, Ruth. I hope you can all hear me okay. I can't see presentation yet, Ruth. I don't know if that... there we go. Perfect. Thank you. Ruth has kindly introduced me saying I've got a lot to say. The difficulty as a fire engineer, I think in the current climate, it's a bit difficult to say much about things that don't burn. But in order, I thought what I would do today is share a little bit about our experiences as a company in terms of what we're seeing from many sort of factors, really. And of course, looking at some slightly different angles of designing with non-combustible materials and really asking the question, actually, is it that simple? So our experience really is quite broad. I mean, as a company, we're involved in many, many aspects of design, and we also do a lot of litigation, a lot of expert witness work, as I'm sure many of you are involved in. But what that does, I think, when we do work with claims and litigation, is understand the really key points of when these points go wrong. We have the opportunity to be able to see many, many areas where things don't quite go as expected, and perhaps gives a bit of an insight about where some areas need improving. Now, to be perfectly honest, when there's the announcement a few years ago about the onward design of buildings being over 18 metres and the exclusion effectively of materials of not limited combustibility, we didn't quite know where I think we were going to sit as fire engineering, because for years and years and years, you've been involved in the design of buildings that, to some extent, cladding systems are going to burn. They're designed to, but maybe to a restricted level. So, of course, we didn't know where this was all going to go. So, as a fire engineering profession, we didn't know if we were going to be fired, and that was it. That was going to be the end of it. But as we're finding, the reality is certainly not the case. And we're being involved more and more with jobs from new build, from designs of new buildings with non-combustible cladding systems, down to the refurbishment of buildings which perhaps need cladding replacement, and also that in-between area where everyone's struggling a little bit at the moment. So how can we mitigate buildings that may have some combustible cladding on, and we might need to mitigate that to a reasonable level of risk? Now, I appreciate things have moved on in the industry slightly, and we've now got I think, better guidance than what we certainly had a year ago. But I don't think that answers all the questions. And that's certainly, I think, a few of the bits which I'd just like to briefly talk about today. So what generally happens then, I think, with fire engineers at the moment, where and what do we do? Well, obviously, this is just a snapshot, a few things, I think, which we tend to get involved with. But certainly at new build, if I'm being blatantly honest, I think we're brought in many times to offset the designer's liability. And why wouldn't they? Why wouldn't they do that? I totally get that. But certainly basic design approval and material ratification, we're seeing a lot of stuff, really basic details now being sent to us to just give us the rubber stamp and say, are we happy with it? Now, I think the difficulty which a lot of fire engineering companies have with that is that the insurance world at the moment is quite difficult, as Jim sort of alluded to in a slightly different way. But from a professional indemnity insurance perspective, for any fire engineering company, it is quite tricky. So certainly the exclusion that we've seen on all the policies out there at the moment, which fire engineers are struggling to do, is be able to comment on specific products. So that limits to what you can actually approve to some extent, which is actually quite tricky. But that still doesn't mean that you can't provide functional advice and give a bit of a steer to maybe that the system and the design is correct, but not maybe just comment on those individual products. And of course, we've got the difficulty now with existing buildings, and we'll talk about that a little bit more in a minute, about proportionality and replacement. We've got a situation where if buildings don't have fully non-combustible walls, we might now be looking to mitigate to some extent with utilising non-combustible materials. And of course, that is again looking things like the actual uses and materials rectification, design approvals, maybe have to do a fully fire engineered approach. And of course, past the 1980s has opened the world up to everyone to do these assessments, which is bringing its own difficulties, as I'm sure you're all very familiar with. But also, I think we're putting a lot more now to actually do on-site inspection, almost take a role of a clerk of works in terms of proving things now. I think from our experience, the industry has moved on massively in terms of the level of engagement they want from fire engineers. I mean, if we consider years and years ago, we were the people that were very rarely brought to design meetings, and quite frankly, what you said was taken as, yeah, okay, that'll do. You'll throw a fire strategy together, and by the time that we see the building sort of 4 or 5 years down the line, when it's actually been built, it actually bears no resemblance to what you put in the fire strategy, where from our experience, that could not be further from the truth now. They want you in at the point of initial concept, all the way through all the stages to the point of handover. You feel a lot more integrated now, I think, as part of the design team. And of course, we've got the EWS1s, and everyone knows, I'm sure, has had many experience with the EWS1s over the past couple of years, and that's still continuing. I think that it's brought its own difficulty. I think in the early stages with the EWS1, I think it was a very binary system, which my personal view is I think a lot of buildings were being remediated or changed, shall we rather say, unnecessarily to bring them fully to non-combustible when it may not have been required. And of course, the offset of that, where a lot of these issues are being found, is it's now expert witness, and we have an awful lot to do with that, as I said, because there's an awful lot of these cases going through litigation. So I'm not surprised why insurance costs are through the roof at the moment. So of course, is there a difference in when we consider about how these buildings are being built, how they're being remediated? Is there a difference in terms of their risk? Now, we know quite obviously all the high-rise stuff over 18 metres is pretty simple now. We know the changes coming in a few weeks' time down to 11. That's putting a real focus, I think, on the direction of where the government and ultimately the regulators are taking this in terms of acceptability of combustible materials. However, that still does leave us with a small problem. So that's fine where we've got a building which is lines on paper and we're designing from scratch. However, as we know, that isn't the reality of the system. We know full well that there are many buildings out there which don't comply to current standards, even though people may be putting reports out there saying, actually, no, we need to rip it all off. But the key question I would ask as a fire engineer is that proportionate to the risk? So what are the options available in reality with these existing buildings when we think about the use of non-combustible materials? Well, of course, the easy answer, and as many people do, if there's any doubt, is rip it all off and start again. So full replacement of materials to that of non-combustible, so it complies. And that would arguably be the safest approach, but I appreciate from a fire engineering perspective, there's also other matters that have got to be considered, which I appreciate many colleagues from building control and whatever you could iterate further on. Of course, there is the area where we can just replace some elements of the system to perhaps bring it into compliance with former standards, bringing that level of risk to an acceptable level rather. And of course, the last bit, which is happening less and less, is using products of perhaps a slightly untested nature, or rather bespoke way, to try and bring that risk down to an acceptable level. And I sort of show that with the photograph there up in the top right of a bespoke cavity barrier system. This is why I'm particularly interested in some of the work there what Jim's doing, because there are systems available which are out there utilising non-combustible materials to mitigate the risk of combustible materials. Okay, it might not comply fully with the requirements of the building regulations, but when we consider the incumbent fire safety legislation, which is what is the requirement for existing buildings, does it bring that risk to an acceptable level? Of course, that's up for debate and will vary from building to building. But certainly, as a fire engineer's view, and my personal view, is that we don't need to be ripping off all materials off of all buildings. It might not be proportionate in all circumstances. But what is the reality of that, though? What are we finding? Even with the new build non-combustible materials, and I'll talk about through a bit of a very brief case study on this, is we're still finding workmanship and design issues in what should be, as we've just spoken about, a very simple world of designing with non-combustible materials. But the reality is that isn't the case. So a very recent job up in north of the country, we were brought in to assist with the design, reclad rather, of a building in fully non-combustible materials. Should be very, very simple from our point of view, and probably everyone would probably agree with that. Apart from they didn't really involve us in the design early enough, and they went ahead and built it. And the fact is they had an open cavity, which was 800 millimeters in depth for the full height of the building of 25 meters. So real basics, that we would all consider. We'd look at it and think, how did you possibly miss that? Yet they did. So in reality, the fact is people were still getting this stuff wrong, even with the most basic of designs. From our experience, I would say that there's a roughly sort of a 50-50 split in workmanship and design issues, from design, from maybe the architectural aspect, all the way to contractors fitting on site. I would say it's probably, again, people may have different experiences to us, but I'd say it's about a 50-50 of what we're seeing around that. And of course, all of the reasons to which you're seeing there, even with non-combustible materials, using them maybe with combustible materials, is it right compatibility? Particularly, I know there's already questions coming in about the robustness of cavity barriers. Absolutely, they're things that we need to be questioning. But one of a few of the things really that we're seeing as well is assumptions in relation to material performance. I looked at a report only yesterday, in fact, that stated very clearly that that cement particulate board is non-combustible, so move on. Is it? Not all of them are. Again, assumptions that materials may be non-combustible when they might not be. people being the classic owing to its wood content. But I think the repeating thing that we're seeing again and again, particularly with any claim case, is that people will be engaged too late and they're not being adequately supervised. They are the key things that we are seeing. So how do we take this forward then? I mean, I'm sure often in many projects, fire engineers are seen as an unnecessary expense, but not necessarily needing to be a fire engineer certainly on a non-combustible design. But we would certainly recommend that a competent designer is engaged ASAP, so we don't have the problem that we had up the north of the country, that a full design is cracked on and they haven't included cavity barriers. I mean, how on earth do you miss that? Incredible. A key thing as well is certainly don't be just relying on assertions in product literature and maybe BBA certificates. Now, this came to the threshold certainly in the recent case, which I'm sure you're aware of which is Martley versus Mullally, where it says clearly in there that there shouldn't have been the reliance on the BBA certificate in isolation. I know that case quite well. I was involved certainly in the early stages, so that is a key thing there. The architects or the contracts effectively relied solely on the BBA certificate, amongst other things, for saying that the product was suitable. Do a little bit more digging. Look, that's what we would certainly want to do as a fire engineer, and I'm sure many of you do. Do some digging, try and be robust with asking for test certificates, test procedures, importantly, seeing how those materials have been used. Third-party review of designs, we welcome. Absolutely welcome. Many of our clients say we want to get a third-party review. We do third-party reviews of other fire engineering companies, and we would certainly hope that other clients do that as well. You know, in this day and age, we're not precious, and I certainly hope that none of you are in to throw a design to another company to pick holes in it. I'd rather get it right. Yeah, but we all make mistakes. We're all human. The regular site inspection stuff we all know about, you know, that's been going on for years, but I would certainly be passing information back to the original designer, the fire engineers, or the competent designer to make sure that they're happy with that. And if on existing buildings we're going down the route of incorporating combustible materials within our design, using non-combustible materials, make sure that there's those robust testing details available to ensure that whatever you're doing is actually going to do what it's meant to do. And of course, the question which I ask is just the proportionality. Now, I appreciate that we're trying to talk a lot about building with non-combustible materials, but if we're using it for reclad, is it actually proportionate to be ripping everything off? Is the risk there? Can there be a halfway house within that? Now, I appreciate from a lot of your perspective, there'd be all other areas which people are interested in, but solely from a fire point of view, a life safety perspective, I would be looking very much at proportionality and trying to formulate an appropriate risk assessment. I appreciate questions are going to be coming through at the end of stuff, so really just want to give you a bit of an overview, I think, to where we sit as in the fire engineering world, and I'm sure there's many fire engineers in the audience anyway who would probably either agree or disagree with what I said, but certainly we find that I think the world's moved on, and I think you're just going over a few of the points there. I think design using the materials which we're using now do have to be considered regardless of where people think they sit in their risk status, but happy to answer any questions a little bit later.
Thank you very much. And we are already getting some questions coming in. Do please send more for all the speakers we've had so far, and also for our next two speakers when you listen to them. Of course, as always, it's the existing buildings that really cause the problems. Very interested to hear that. We're going to come on to our fourth speaker now, who is John Duffin, who is Managing Director at Keyfix. And I know this is an area of great concern. John, over to you.
Morning, thanks, Ruth, and good morning, everybody. My name is John Duffin. I'm the MD for the Keyfix business within the Keystone Group. I've been working with the Keystone Group for 27 years in the development and launch of several products, the early days of Keystone lintels, more recently for 18 odd years in Key light roof windows, and then recently took up the non-combustible challenge when we were approached by a customer to develop a system to deal with cavity trays. So next slide, sorry. Oh, the slides are. So anyway, luckily, so we'll not dwell too long on the first three slides in the presentation, because luckily we've had three experts in Richard, Jim and Jamie to take us through the details. But we all know the disaster that occurred in June 2017. And I suppose the only good thing that kind of come out of that is to bring it to everybody's attention, just as Jim said, how coincidental all these things have happened, but it has brought forward the regulatory review of the approved document B, which came into effect in 2019. And that regulation, so the next slide, so that regulation, I suppose, banned combustible materials or in some buildings over 18 metres, and it gave them a level of combustibility. So A2, S1, D0 being the minimum standard allowable. And I suppose, to bring that some context to cavity trays, before the world of non-combustible cavity trays, it was traditionally a heavy piece of black plastic PVC or plastic or polyethylene used across the cavity. And the non-combustible world, the rating of A2, S1 and D0 is the A is how combustible the material is. The S is how much smoke it produces when it becomes into reacts with fire. And the one that, to bring context to the cavity tray world, is the flaming droplets. So the heavy plastics that were used in cavity trays traditionally, when they come in contact with fire, melt and form flaming droplets. And those flaming droplets can drop down the cavity, landing onto a duct or something further down the building, and start the fire spreading downwards as well as upwards. So very, very worthwhile review of the whole systems. And I suppose from my perspective, we are going to talk about the challenge that came about. So it's very easy to use the traditional DPCs or plastic cavity trays. But whenever you go to design a new product, we're going to talk about the challenges that come up with that. So it would be remiss of me to not mention, and I know Richard mentioned it earlier, about the temporary exemption. So this is not a sales pitch for cavity trays or anything like it. There is an exemption currently in operation. That exemption came in June of this year. It was based on a consultation, as Richard explained, that took place 2 years earlier than that. And whilst that consultation was taking place, we were in conversations with Barrett Homes, who approached us in the first place. I suppose the exemption, it is in until the end or December 2023. And as Richard pointed out, there is issues with passing plans and getting your approvals, and then starting a building which may end up either completing outside of that exemption period and all the problems that go with that. Luckily, the industry has responded responsibly, in our opinion. Most of the major house builders, contractors that we're involved with have all agreed that the exemption is no longer necessary. They have agreed that, they also have agreed, a lot of them have come to the realization that cavity trays, which were probably in the consultation described as being an insignificant function or feature within the fire spread of a building, have realized that cavity trays are one of the only, if not the only, material in a building, the facade of a building, that passes horizontally through every vertical compartmentation barrier. So they've realized that it is a big issue. And luckily, people like the NHBC and other warranty providers have stepped up and said, well, guys, this is best practices, what we should be using, and that they are continuing to promote that. And we're seeing more and more contractors and developers and house builders saying, well, actually, it's not worth the risk. We know there are known now viable alternatives to combustible materials. Why would we use a combustible material, especially now that we've seen recently some of the legacy issues and the retrospective remedying of buildings. So for the first time, we've seen that, and it's made I think the industry take the issue a lot more seriously. So next slide. So how we got them into the world of non-combustible cavity trays? We were approached by the technical manager of high rise for Barrett's at a conference, and they said, guys, we're very impressed with what you did with the roof windows. You took a very standard product, you innovated a lot. Have you ever thought of cavity trays? And I said, no, I know nothing about what's the issue with cavity trays. And he started to explain the change in regulation. And because of our background in the roof windows and flashings of materials of the roof windows into the roof of a building, they said, could you look at cavity trays for us? So we had a blank canvas. We knew nothing about cavity trays, and that was late November. By early January, we had sat down with NHBC, the BBA, BRE, Premier Guarantee, various house builders and brickwork contractors, and said, guys, if we are going to develop a cavity tray, a non-combustible cavity tray system, what are the boxes that we need to tick? And I suppose we also sat down as best practice, and we try to, as a Keystone group, try to champion best practice always. We sat down and we said, also, when we're designing this new system, can we also think about all the things that don't work with traditional cavity trays and the use of plastic DPCs? So very quickly, we came up with a list, and it would have been beautiful. It would have been 10. It would have made that nice slide nice and symmetrical. But there was top nine areas of performance that were identified. So the first three are pretty a bit of a given. If you're going to develop a non-combustible cavity tray, it must be non-combustible. But when we were sitting talking to all the stakeholders, they had said, go for A1. If you can develop an A1 system, why develop anything lower than A1? Because the regulations are unlikely to relax. It will only ever get more stringent. And if you develop with A1, then you've nowhere to go backwards. Of course, the lifespan and durability of these buildings or these materials. So we're putting cavity trays into a building that's the facade's covered in brick. Nobody puts a brick facade on a building and expects to take it down in 50 or 60 years' time. These buildings are lasting for hundreds of years. So you have to make sure that you design a material that or design with a material that will last the lifespan of the building and the true lifespan of a building. Weather tightness, of course, it has to keep out water, and we had to get third-party approval. And we were very lucky that Richard introduced the accepts scheme for us whilst we were going through that testing, so that it allowed the industry to get moving. The next after that, then it became more of a challenge. So, of course, metal cavity trays are the common solution for non-combustible cavity trays. So we had to make sure that there's no thermal transmission. These are metal trays, so they're not as flexible and as malleable as plastic in the past. So they had to have not cause any differential movement issues. Preformed corners, because there are tapes and mastics being used everywhere, and everyone is looking for a system. And even as Richard described earlier, that even in combustible products, they're looking for a system now where you have less and less reliance on people site forming corners and junctions. We had to make sure that we resisted any introduction of a slip plane. Slip plane forms whenever you break the bond between two courses of brick. So we had to develop that. We had to make sure that we didn't create any condensation within the cavity and within the insulation. And of course, because it's a new product, we had to make sure that we provided a good education piece, because this is something brand new that's landed on the scaffolding. They've been used to using something for the 60 years before, and now you're introducing something new. So we had to come up with really detailed installation, set out drawings and whatnot to allow people to install these as a system so that it's robust enough to do its job. So addressing each of those performance challenges, and we addressed, as we went along, we addressed some of the issues that were existing with traditional materials. So easy for the Keystone group, as a group of metal bashers, we selected stainless steel very easily and very early on. Stainless steel, fully A1 rated non-combustible, and because we don't add any other pollutants or any other materials to our system, we don't have any tapes, mastics or anything else, only stainless steel. It actually is 100% recyclable, and it adds to the query that Jim was mentioning earlier on about sustainability, and it starts the argument: what's more sustainable, something that you can constantly recycle and use in the building, or something that you start from scratch and it's throw away or less energy you produce but throw away at the end of its use. And of course, the lifespan, as I said earlier, when we put these cavity trays inside a facade of a building that's going to last hundreds of years, we need to make sure that the material we use lasts that length of time. And the thinnest piece of material that we use is 0.5 mil thick stainless steel. And the British Stainless Steel Association gives us, in a semi-industrial environment, gives us 140 odd plus years of pit life corrosion. And because these are built inside buildings and inside a cavity wall, they don't even get that level of exposure. So well and truly ticked all those boxes. Water tightness. The one thing that when we sat down with both the NHBC and BBA was that the water tightness of a building, and if you use a traditional cavity tray and you run it right around a building and you have water coming in one area, it can track along on top of a DPC or a cavity tray until it finds a joint or a gap and leak in. But it leaves it very hard to find out where that water is actually coming in the first place. So we decided that we'd make the trays in modular lengths, and at the end of each module, the longest module we make is 10 bricks long, but at the end of each module, we formed stop ends, integral stop ends on the tray, and we formed that out of the technology we used in our roof window flashings by draw forming. And we draw form the stop ends on either end of the cavity tray, and it makes it very robust. It means any water that lands on top of that cavity tray can only travel a maximum of 10 bricks long before it meets a physical stainless steel one-piece stop end. There's no joint for it to leak through, and it means that it makes it very robust and water drains out through the weeps. Then, of course, introducing a metal product that's fixed to the inside leaf and built into the outside leaf would cause issues with cold bridging, and it would cause issues with differential movement. But because we formed those stop ends on the end of our trays, it made the tray very, very rigid, and it meant that the tray is self-supporting. And in one meeting we had in particular, it was brought up and said, guys, you realize that this tray is very, very rigid. If you build it into the external leaf, it's self-supporting. It doesn't require any support from the internal leaf. And if you do that, you don't need to fix it the internal leaf. And the reason why flexible DPCs and cavity trays in the past have to be built into or fixed to the internal skin is because they don't support themselves, and they drip or drape across the cavity and sag and collect water. But by not touching the internal skin, we were instantly able to solve two of the biggest problems. One, no cold bridging. The tray is built into the external leaf and it terminates within the insulation, but it doesn't actually touch the internal skin. So we get very, very little thermal transmission. And because it's only built into the external skin and not fixed to the internal skin, we have no issue with differential movement. The external skin can expand and contract with the weather, and the internal skin we hope isn't moving. So we don't have any issues. And to back that up, we did a BRE study. So we asked the BRE to take all the A1 rated cavity trays that were our non-combustible cavity trays that were in the market, and we asked them to run a thermal modeling on it about how much heat transfer there is at each floor, because each of these cavity trays go round above the fire barriers at each floor, and it's quite a significant amount of it in the buildings. And our nearest competitor was 3 times worse. So the psi value calculated with the system, our next nearest competitor was 3 times worse than we are. So by not touching the internal skin, we have solved one of the biggest problems, especially by using stainless steel. Other systems use aluminium and different things that conduct heat even more. So we were able to tick that box and solve that problem. And of course, then the slip plane that I mentioned earlier on, big concern at the very, very early days by introducing a sheet of steel within the masonry joint. But in the Keystone group, we've been lucky that we've been indenting the internal flanges of lintels to form a plaster key, and because of that plaster key, we are able to the mortar below the tray embeds up into the key, and the mortar above it embeds around it, and we can get continuity of the brickwork bond and solve that problem. And as I mentioned earlier on, and as Richard mentioned earlier about the systems and making sure that we develop systems for these products, all our cavity trays go out with preformed corners. No one has to cut, form, or make anything on site, including our stop ends at reveals or anywhere else. Those are all pre-made and in the factory, and we were able to develop that with. And if you look at on the image that's there, we using our roof window technology, we were able to develop a system that doesn't require any tapes or mastics to make those joints. And the way we do that is because if you put 2 pieces of stainless steel one on top of the other, capillary action would suck water straight through between the two, and you'd have a leak in the corner. But by introducing those little ribs that you can see on the image on the slide, those little ribs break the capillary action, and the water will seep through and then drop into the little rib and weep out through the front of the tray. And it means that we don't use any tapes or mastics. And that is always seen traditionally, was mentioned to us in one of the very first meetings we had, was the single biggest reason for reopening up a cavity wall of a building after the building's been occupied was down to joints in DPCs and cavity trays using tapes and mastics. So we were able to eliminate that by introducing the little ribs at the joints. And what that does do is that it also gives us a non-destructive test. If you put 2 pieces of stainless steel together and mastic them together, how do you know the joint's good? You don't know. You pull it apart and you go, oh yeah, the joint was good. But we have developed a system where you can check that joint by a non-destructive means and check that it's clear from any mortars or debris. And if it is, then the joint weeps all day, every day. And as the very last point, in the top 9 areas or performance areas that we were asked to address, we do provide full markups. We do a full take off of all the components, and we give the bricklayers a full set of drawings that details part by part right our way around the building. It's like like paint by numbers, so that you can part A goes there, part B locks into it, and they go right around the building. And we do full toolbox talks. We turn up and we talk the guys through it on site at the very start, because it is a massive education piece. When you launch a new product and you bring something new to an industry that is generally slow to move, you have to invest heavily in the education part to make sure that what you've designed and what you've gone to all the bother to make and draw up, that is installed exactly as it should be. And that brings us to the end. So this is my favorite slide always. The Keystone Group, we are known as innovators. Innovation never sleeps. We do sit down and we do listen to everyone, and that's how we've come up with all the innovations that we have and the products we have. And hopefully from the previous 10 or 12 slides, I've been able to demonstrate that when the industry is challenged with something to develop and make something new or better, that it doesn't necessarily have to cause huge issues for everyone to develop them. So thank you for that. I see some questions coming in, and I look forward to answering those at the end. Thank you.
Thank you. Yes, there are some really interesting questions coming in. I think it was great to actually see through that process of development. And I have to say, as somewhat of an outsider, I've been wondering all the way through these presentations, if you have a non-combustible product, why on earth wouldn't you use it, especially in a building element, which surely cannot be that expensive in terms of the overall building. That's something for discussion later. We're going to move on to our last presentation, and it will be from Marcus Emerson at IG Masonry Support. Now, unfortunately, Marcus can't be with us today, so he's pre-recorded his presentation. But please, if any of you are moved to ask questions, please do put them in the questions, because his colleague, Andy Charlotte, who is Chief Designer at IG Masonry Support, will be with us to take those questions. So it's not going to just be a one-way presentation. So now we will watch Marcus's presentation, and then we will go on to our discussion area.
Thanks, Ruth, and thank you to all the other speakers today who've given their insight into designing with non-combustible materials. As mentioned, my name's Marcus Emerson. I've been with IG Masonry Support for over 8 years now. Started off as a technical engineer, then progressed through to the role of technical sales manager, and now I head up the estimating team as the estimating manager. Being with the business for a number of years, I've seen firsthand the changes across the industry in terms of regulations and how these changes have affected the way the business operates and also designs and manufactures its products. It's fitting that I follow on from John, as IG Masonry Support work closely with Keyfix to ensure we remain ahead of the curve in terms of regulation changes, and with collaborative estimating teams, our products are quoted and specified to ensure our customers are meeting and exceeding these regulatory requirements. So if you don't already know, IG Masonry Support were founded by the Keystone Group in 2015, when it was approached by a few industry leaders to develop a range of masonry support products. Now, IG Masonry Support designs and manufactures the most practical and advanced range of patented stainless steel masonry support products and revolutionary brick slip soffit systems for the construction industry. Within IG Masonry Support, a large proportion of our projects are over 18 metres in height. We have always been a step ahead in terms of innovation, but quality and safety is never compromised. Rigorous testing is always carried out on all of our products. This is proven with our long list of BBA certifications, the real rubber stamp of a reliable, well-made product. After the horrific events of the Grenfell Tower Fire, many questions were posed about the risks of fire in tall buildings, and of course the decision was taken to ban combustible materials within the building envelope for buildings over 18 metres in height. This had a huge impact in the industry, as we've already heard today, but what impact has this had on our IG Masonry Support design and construct for tall buildings? The single biggest consideration for IG masonry support is the coordination of the various products that are required to fix to the face of the slab. On a typical 225 to 250 slab, you have to coordinate balcony brackets, masonry support, cavity trays, fire barriers, window supports, and the list goes on. This is a lot going on within a relatively tight space. The new regulations have rightly put the likes of the cavity trays and the fire barriers as the top priority. This has, however, resulted in the likes of our structural support systems needing to be adapted and designed around these products as to assure their effectiveness isn't compromised. An example would be the changes in some of the advice around penetration of fire barriers. This is something that has reduced considerably in some cases since the new regulations were brought in. As already mentioned, the Grenfell Fire has resulted in the banning of the use of combustible materials in new high-rise buildings. This means that all products within the external envelope have to be made of non-combustible material. Due to these changes, specification has become even more important, and rightly so, as a result, much harder to break. So dependent on contract type, the specifier or contractor has to be very vigilant and aware of what effect any changes to spec may have on the Part B document. Therefore, the necessity and weight of spec has certainly become much greater. It is now more than ever vital to guarantee safe spec from the outset. RWMS, or welded masonry support, is a large part of our core product range, used to provide horizontal movement joints in brickwork. Two major changes or things to consider following the regulation changes were the actual material used to manufacture certain products, namely the cavity trays and thermal isolator shims. John has covered the cavity trays in more detail, but the materials used for these products are night and day different now compared to pre-regulation change. Formerly, these would be a polymer or plastic type material, which has now changed to a much more robust material, in Keyfix example, stainless steel. IG Masonry Support's thermal shim is designed to minimize heat loss through cold bridging, improving energy efficiency of the project, whilst also eliminating bimetallic corrosion when it may come into contact with mild steel. The material in which we manufacture this product had to change with the new regulations. Formerly made using a polymer, we have now introduced an A1 fire rated shim that is supplied as standard with any bracket we supply. We also have a range of prefabricated brick slip products to help architects and contractors achieve intricate brick features on facades. Our BOSS, or Brick on Soffit system, has been through quite the life cycle since its launch in 2015, mainly to improve the performance and sustainability of the products, but more importantly, ensuring we're ahead of the curve in terms of complying with regulations. Our original BOSS is a patented brick slip system where the bricks are bonded to a perforated steel carrier, which is fixed using a consistent channel placed through the top of the unit. When the changes came into force, the first response from IGMS was BOSS Plus, which incorporated a change in the adhesive and the addition of a mechanical fix of the bricks to the unit. The system was designed to meet approved document Part B. Superseding BOSS Plus, we then launched our BOSS A1. This is the most advanced system to date. It is a carbon neutral product with mechanically fixed brick slips, fully BBA approved, and most importantly, it is manufactured completely from A1 fire rated materials and is document B fire safety compliant. To bring the topic of non-combustibility to life, I'd like to bring your attention to one of our recently completed projects, Southmere Village. The Southmere housing development is being built as part of a regeneration project designed to revitalise the Harrow Manor Way area of South East London. IG Masonry Support supplied products to buildings C1, C4 and C5, totalling 9 blocks, The entire development is valued at £126 million, and IG Masonry Support's product package for this development is the largest the company has supplied to a project since its inception. The introduction of new building regulations set out by approved document B meant the brickwork contractor, Landmark Brickwork, needed to find products which met the conditions. IG Masonry Support's Boss Plus met these standards, making us an ideal choice for a supplier. The final question that is asked of us within this webinar is how we ensure quality and competence on site. As mentioned at the beginning of the presentation, IG Masonry Support and Keyfix work collaboratively to ensure we coordinate our products appropriately in any projects that we've both been specified for. This gives our customers peace of mind that due diligence has been done and any potential clash points are identified early and adaptations are made. As a business, we are dedicated to manufacturing and supplying the highest quality off-site products, which no doubt aids the potential lack of skilled resource that is currently being experienced in the sector. This dedication was clearly demonstrated earlier this year when we were awarded our BBA ISO 9001 Quality Management System certification. When our products are delivered to site, it doesn't stop there for us or our customers. We have a site engineer who visits our project sites, works with the install teams to ensure installation is carried out correctly. Our customers are happy with the final product and also liaises with our technical team back in the office to iron out any issues that may arise. So I'm hoping that I've answered all the questions that this webinar has posed today in terms of designing with non-combustible materials. I'm sorry for not being able to be there live today. However, all of the rest of the speakers on today's session, I'm sure will be able to answer any questions you may have. If there are any questions specific to IG Masonry Support or my presentation, then please do pop them over on the question box and they'll be passed on to me and I can follow these up after the webinar. Thanks again for joining us today, and I'll pass back to Ruth.
Well, that was very interesting. And of course, you can ask your questions and of course they can go on to him. But as I said, we are also lucky to have Andy Charlotte here who may be able to answer those questions. As John Duffin said at the end of his presentation, there are some interesting questions that have come in for him. And I'm going to put both of them to him first of all, and then see if anyone else has anything to add to those. So the two questions are, one is, would you need to dress a breather membrane into or onto the tray, or is it okay for it to continue behind the tray? And the other question is, with the Keyfix cavity tray, I've seen on some sites that the lapping bridging the vertical face of the CP board onto the cavity tray is EPDM, which is combustible, and extending 100 millimeters onto the tray. Lapping a combustible material onto a non-combustible product seems counterintuitive.
Yep, excellent. Thank you. Thankfully, both questions. That's very good that they're both in a very similar thread. Yes, we do recommend that a membrane overlaps the top of the tray. The membrane should, of course, continue on down the back of the tray also, but we ask for an additional strip or rip of membrane to be put across above the top of the cavity tray. And the reason for that is purely to facilitate, as the building dries out, any moisture or any condensation that might be within the insulation, that it has somewhere to get out onto the tray. And the question that was raised about overlapping a material that is combustible onto the top of a non-combustible tray is very, very relevant and a very good question. We do specify that it overlaps onto the top of the tray about 100 millimeters. The reason for that is because it won't penetrate out, or it shouldn't penetrate out through the insulation. We would bring that to people's attention to not allow the membrane to come out through the insulation. The insulation, of course, will be non-combustible. It'll be compression fitted above and below the cavity tray, and the membrane should never ever penetrate out into the clear cavity. The function of a cavity tray is to capture the moisture running down the back the inside surface of the outside skin of the brickwork, and to capture any moisture dripping off wall ties or anything within the clear cavity. Our tray will then go beyond that and embed back into the insulation, and it's generally 15 or 20 millimeters or something like that from the internal skin. And that's the bit that the membrane overlaps on, and the membrane should not overlap or protrude any further out through the insulation. Very, very valid and very relevant points. And they are covered in our fit instructions and are covered in our toolbox talks. And hopefully that answers both of those. Definitely agree. Membrane should be there, and it's there to facilitate the drying out of the building or in the insulation as the building dries out, but should not penetrate out through the insulation into the clear cavity.
That's brilliant. Thank you. Now, we've had a couple of questions from one of the attendees, Michael Moose, who's obviously very concerned about aluminium in buildings.
Yeah.
And he says, the maximum service temperature of aluminium, which is seen as a non-combustible material, is 150 to 180 degrees. Aluminium framing and bracket anchoring systems widely developed, used in the facade business. Even though every test according to BS 8414 shows failing of the facade parts during the 30-minute tests. He talks about facade fires at 800 C, and he's come back to us again and said, I don't get it. IG Masonry and Keyfix make tremendous quality products and insist on the integrity of their products according to fire protection. In the meantime, they face brick slip systems anchored on aluminium and that will melt and be ruined if fire occurs. So I don't know, maybe Jim, do you have something to say about the use of aluminium?
Well, yes.
Sorry, Jim, could I just join in on this? The first thing I would raise with this one for Michael is that we do not use aluminium in any of our products within IG Masonry Support or Keyfix. So that is an incorrect.
It's all stainless steel. Yeah. Exactly for that reason.
Yeah.
Yeah.
I think there's a wider question, because obviously we're not just talking about your products. There's a wider question. Thank you very much for that clarification. But the wider question is about the use of aluminium in facades. Jim.
Right. So this was a concern back in 2000 for insurers also. We conducted a research program, cost about £300,000 then, where we burnt 4 layers of, at full scale, of the normal curtain glazed walling systems 21 times. It was a very very large project, and now at the time the insurance interests were looking to see what the scope was for flames hopping between floors and whether the melting out and detachment of the of aluminium based systems would contribute to this leapfrogging. Now, at the time, we did actually demonstrate quite nicely that actually, yes, the brackets do melt through. The front of floor slab barrier that you have, fire stopping that you have, is generally a compression fit. And once the spandrel panel has broken, being glazed often as not, the truth is fire doesn't even have to break out to break back in again. It can go behind. It can go behind the cladding system. But what was absolutely remarkable was the failure time. Basically, the glazed panels would break within 10 minutes. And actually, the spandrel panels and the transoms and the mullions would be consumed within 23 minutes. And we were having large chunks falling off really in less than half an hour. So absolutely right to raise it as an issue. However, at that time, we were dealing with office blocks. And the one thing we did know about office blocks is they would be sprinklered in that sort of environment. And we demonstrated that actually that affords very great levels of protection to the point where it wouldn't be an issue. The emerging issue we have now is as buildings are reused and recycled, often as not office blocks over to commercial use, they don't necessarily have to be sprinkler protected. And actually, we're also
I think you mean over residential use.
Sorry, residential use. Yes. Absolutely right. Sorry, Ruth. And also we're seeing it used explicitly for residential projects as well in the high-rise environment. And whilst we issue warnings basically saying, look, we did these very large scale tests, and actually it needs to be accompanied with the use of a sprinkler system or some other way of controlling the fire if vertical fire spread isn't to happen, it seems to be falling on deaf ears. So I absolutely share the concern. It's non-combustible, but it is weak and it does fall off. Whilst you've got the comfort of a big concrete floor slab, that's great. But if we start to see aluminium curtain glazed walling systems on types of buildings which either don't have a floor slab, such as modular, or facing more timber type constructions, then really there's going to be a world of pain ahead.
Can I just add on that, please?
Yes,
Jim?
please.
I think Jim raises some really good points, which I agree with all of them. But I think looking at the question, and how Michael's framed it, in particular, I think asking the question, well, we know, as from Jim's research as well, that we do have mechanical failure of these wall systems. So ultimately, is this becoming a risk for occupants and firefighters? Which I think is a very valid concern. And I think coming from the testing aspect, we know that the performance criteria within BR 135 lays very little, if any, requirement for mechanical performance other than effectively risk assessing it. Now, that puts, for me, some further onus now on the cladding designer, because we've got to then consider how that operates in the context of the facade and the likely risks now to occupants and firefighters. Now, I think where we've got systems which may have premature failure, as Jim's identified, above escape routes, could be a problem. And that's something certainly which needs to be considered. Now, I think, and I'm not pointing fingers at any designers, but I do think that for many years that there has been a bit of an issue of ADB blindness to the fact of, well, I've got my ADB here and it complies with ADB, therefore it must comply with the building regulations. Well, maybe not, as we've now started seeing from the Grenfell inquiry, that actually that there have been buildings which you could have got out of ADB and said complied, but of course didn't necessarily comply with the functional requirements. And I think that's certainly where government has been coming from. And that's no different, I think, to Michael's question here. It is that you might have something which may fail prematurely. Now, I've been a firefighter, and one of the things that you would consider at any sort of high-rise incident is falling debris. That is a big thing that you would be interested in. We've all seen the shots from Grenfell where they've had the riot shields over them from the police going in, where they've got the stuff coming down on them. So that would be a consideration. Escaping people might not necessarily have that thought process, and there might be a fire above them with things which need to be considered. So I don't think that should be discounted, but by any way, shape, or form. If there is a possibility of a premature mechanical failure, as suggested in BR 135, then that needs to be considered. So I think specifically with Michael's question is that it is considered within the performance criteria of the documents, but what it does is it gives it back over to the designer to consider, rather than just taking the face value of the document.
Well, I think if one thing we've all learned from Grenfell, or I sincerely hope we have, is that everybody has to take responsibility, that it's not, you can't go, oh, well, it's not my bit, someone else has done that and it's all right. Because whatever the report says, it's just that really disgraceful passing of the buck, isn't it? There's a question that came in at the beginning when Richard was talking, although I notice it's addressed to the panel, and it says, what are the panel's thoughts on the use of open state cavity barriers within a facade, notably the robustness of TGD 19 to determine where these open state cavity barriers can and cannot be used in the facade? Obviously, something that you said, Richard, triggered the thought, and then I'll see what others think about it.
Yeah, okay, thanks for that. It's a bit of a concern for us because there is a limited scope in TGD 19, and what we tend to find is that gets stretched a little bit with various open state cavity closures. So it's an area that we're going to focus on in the next 12 months because we would like evidence, obviously, that open state cavity closures will perform in all of the environments that they're proposed to be used in. And I would suggest that sometimes that's stretched a little bit. We would, again, the TGD 19, as far as I understand, is not a UCAS accredited test. I think it's an industry test as well. So, and I can be corrected if I'm wrong there, we would have a preference that there would be more of a durable testing method in relation to open state cavity barriers.
Yes, Jim.
Yeah, so I think the wisdom of TDG19 probably has been incorporated into British standard now, although I think very recently. But I certainly share the concern. It's a furnace-based test, and with that you can lose realism. It heats the cavity barrier across the total span, which isn't how it actually happens in operation. One of the things we've looked at, I'll put a link on the answer to the questions there, but we're looking at an alternative form of testing, which actually does, what actually happens in a fire, where cavity barriers actually get are subjected to a point heating source, and you get proper scientific data back about its closure laterally, the rate of closure laterally, how long flames pass for before it does close. These are all vitally important things if you want to match up an open state cavity barrier to the material or to the fire performance properties of the materials that they seek to separate. At the moment, there's no effort made to do that, which seems very odd. We'd like to see it as a pre-qualification to 8414 testing, which is often used as a way of saying that open state cavity barriers work or don't work. But actually, 8414 tests can fail for a range of reasons, which might be nothing to do with the cavity barrier, and they might actually be untested. So we're just looking into this currently, but certainly more data is required so that they can be more appropriately matched to the materials that they occupy space with.
I think we tend to focus on the use of open state cavity barriers and worry about their mode of failure, but there is an argument to suggest it's no different to any other intumescent fire stopping material on the market. Because if we think about many of Envirograph products that fill gaps in holes like intumescent cat flaps, if you test it, by its very nature, it will fail. But actually, you test it 6 minutes into the test and it's done its job, because there's a hole. And all the time you've got a hole in any kind of fire resistance test, it's going to fail because you can stick a rod through it. So you do have to think further than that, don't you, Jim? You have to think about the actual performance.
Absolutely. So, there have been instances where fire has gone from the bottom of a building to the top of a building because the lightweight membranes in there, the breather membranes, actually burn faster and don't have the energy to actually seat an intumescent device. And then you get a fire up in the roof space and you get significant damage. So what have they achieved? It's also important, I don't mean to be derogatory about them, they're very clever products. And let's not forget, before 2000, they didn't really exist. People used to just try and do their best to slim down the cavity a bit with a wood batten. So it's probably still a developing area. The products are clever. They do certainly have a very valuable role to play. And in the future, if toxicity becomes a selection criteria for building materials, and there's more consideration of smoke and toxic gas spread, they're going to be absolutely vital.
Thank you very much indeed. Unless anyone, I was going to say burning, but I won't. If anyone's dying to make a final remark, this is your opportunity, because we really are now running out of time.
Yeah. Well, there's one final comment I'd like to make about Michael's comment about fallen debris. I mean, yeah, we've designed out the aluminium. We don't put aluminium in any of our products, Keyfix or IG masonry. And also the brick slips on our system are all mechanically fixed, and they're all mechanically fixed back into the back end structure. So, and again, stainless steel fixings, so that in the result of a fire and burning, there should be no fallen debris on firefighters or escapees. So very, very good questions. Very, very informed people. Very good.
Thank you very much. And I would like to thank everyone who sent in questions and everybody who's been watching. I certainly found this fascinating. I think it's been sort of 3 parts reassurance, because there is such good development going on and so much knowledge and so much will to make things better. And sort of 1 part worry, because it still seems as if there are things around which, even though the knowledgeable people on this panel know about, are not being put into practice, and there is still too much bad practice. And we just know how wrong that could go. This is the 4th in a series, and unfortunately it's the last in the current series. They've all been so interesting that I'm sure there will be more I think it just remains for me to say that thank all our speakers who have been fantastic, whether they've been here in person or in the case of Marcus for very kindly recording something for us. I know this will shortly be available to watch again, and I think to share with your friends. Thank you very much, and goodbye.